Hello everyone, I am Roshni Jain. Today we are going to discuss about the concept permutations and combinations. So basically the permutations are used the arrangement of any group and the combination are used the selection of the any group. Now the important formula is that factorial notation, let n be a positive integer, then factorial n denoted by n factorial and defined as the n factorial is equals to n into n minus 1, n minus 2 and so on 3 into 2 into 1. That is the continuous product of the first n natural numbers. For example, 3 factorial which is equals to 3 into 2 into 1, that is equals to 6. 4 factorial is equals to 4 into 3 into 2 into 1, that is the continuous product of the natural number which is equals to 24. So 5 factorial which is equals to 5 into 4 into 3 into 2 into 1, that is equals to 120 and so on. As a special case, we define the 0 factorial is 1, but 1 factorial is 1. 2 factorial is 2 into 1 and the 3 factorial, 4 factorial and so on. Now the permutations is a very important. The number of all permutations of n things taken are at a time is given by npr is equals to n factorial upon n minus r factorial. Second formula is that number of all permutations of n things taken all at a time is n factorial. So number of permutations of these n objects is equals to n factorial upon p1 factorial into p2 factorial and so on pr factorial. That is, if there are n objects of which p1 are like a one kind, p2 is the second kind, p3 is the third kind and so on, pr is the rth kind, such that p1 plus p2 plus p3 and so on pr, that is equals to n. Let us see the examples. How many ways a 3-digit numbers can be formed using 1, 2, 3, 4. There are 4 options are given here. A is 24, B is 42, C is 50 and the D option is 46. Let us see the solution. Here the 4 digits are given, means n is equals to 4 and they are asking as a to form a 3-digit number, it means r is equals to 3. Therefore, by using the formula of permutation, npr is equals to n factorial upon n minus r factorial which is equals to 4p3 is equals to 4 factorial upon 4 minus 3 factorial and it gives 4 factorial upon 1 factorial which is equals to, so 4 factorial which is nothing but this is the continuous product of the natural number 4 into 3 into 2 into 1 divided by 1 factorial is 1. Which is equals to 4 into 3 into 2 into 1 which is equals to 24 and the option A is the correct answer and the 24 ways of the 3-digit number can be formed using 4 letters. So next, how many 4-letter words with or without meaning can be formed out of the letters of the word logarithms if repetition of the letters is not allowed? Again there are 4 options are given here. Let us see the solution. The word logarithm contains 10 different letters. So required number of the word which is equals to number of arrangement of the 10 letters taking 4 at a time. 10 letters means total letters is n is 10 and r is 4. So npr is equals to n factorial upon n minus r factorial which is equals to, put the value of n and r is a 10p4 which is equals to 10 factorial upon 10 minus 4 factorial is 6 factorial and which is nothing but 10 into, so 10 factorial means this is the continuous product up to 1 divided by 6 factorial. Similarly 6 factorial is also 6 into 5 into 4 into 3 into 1, but in numerator and the denominator all terms after the 6 factorial are cancelled. That's why directly can be written as the 6 factorial in the numerator and the divided by 6 factorial, both are the cancel, and the remaining term is that 10 into 9 into 8 into 7, which is equals to 5040, and the option C is the correct answer. So next, in how many ways can the letters of the word aptitude be arranged? Again, there are 4 options are given here. Let us see the solution. The word aptitude contains 8 letters, and by using simple mathematical logic is that in this formula, so required number of ways, which is equals to number of letters, that is total letters 8 is n, so 8 factorial divided by number of repeated letters. So repeated letters, T is repeated twice. Observe this word, and the T is the repeated twice. That's why 2 factorial, that is equals to, so 8 factorial, which is nothing but 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1, and which is equals to 40,320 divided by 2, which is equals to 20,160, and the option B is the correct answer. And 20,160 ways. So next, in how many ways can the letters of the word leader be arranged? There are 4 options are given here. Let us see the solution. The word leader contains 6 letters. So this example solve in a previous formula also, that is the number of letters factorial divided by number of repeated letter factorial. So this formula also used by this example. Now the word leader contains 6 letters, so L is the only one time, that's why can be written as L is equals to 1. It means this is the first kind. E is repeated 2 times, that is E is equals to 2. This is the second kind. Now A is the only one time. This is a third kind. Next, D letter is only one time. This is a fourth kind. And the next, R is equals to 1. This is the only one time. That's why is the P1, P2, P3, P4 is the fifth kind. Therefore, the required number of ways, which is equals to n factorial upon P1 factorial, P2 factorial, and so on, PR factorial, which is equals to 6 factorial upon, put this value, 1 factorial, that is P1, 2 factorial is P2, P3 factorial is 1 factorial. Next, P4 factorial is 1 factorial, and P5 factorial is 1 factorial, and which is equals to all 1 factorial is 1, and the 2 factorial can be written as 2 into 1 in the numerator. 6 factorial, which is nothing but 6 into 5 into 4 into 3 into 2 into 1, and which is equals to 720 divided by 2, that is equals to 360, and the option C is the correct answer. Now in the next video lecture, we learn the combinations and the example of the combinations. Okay, thank you.